classroom at UBC. Okay? So hopefully there won't be anybody coming in and we can work here a little bit. So we're going to use a little chalk and an actual blackboard in a classroom to do this, these videos. So let's say we have something like this. Okay? Can you see that? I hope so. 5 over 3x is equal to. Let's say we have this equation and they ask us to solve this equation. Okay? Before, this is a general rule that you should always try to do this. Okay? Before you start crunching numbers, moving numbers around and trying to solve an equation, you should take a look at the equation and list your restrictions. Okay? The reason you want to do this is because at a certain point, when you're crunching, when you're trying to solve this equation, you might start losing some of the solutions. Okay? So you have to keep note of your restrictions. As we stated in mathematics, our restriction, one of our restrictions that we're going to have is we cannot divide by 0 because the equation explodes, right? So what we do with this equation, whenever we get an equation, if there's a fraction involved, all we do, we grab the denominator, right? And we say we can't divide by 0. So what we do is we solve for this not equaling 0, and that will be our restriction. Okay. So what we do, we take the denominator and we say 3x cannot equal 0. Because if 3x is equal to 0, that means the denominator is equal to 0, and we're dividing by 0, and we cannot divide by 0. Okay. So if you divide, now you can solve this equation. You solve not equal to signs. Well, they're not inequalities. I forget what it's called. This is an equal sign. This is an equation, and this is a non-equation. Anyway, you solve this. You treat this exactly the same way you do an equal sign, right? So if you want to get rid of the 3 here with this 3 times x, 3x, you divide by 3. You divide by 3. 3 kills 3. So x cannot equal 0. Okay, and this is our restriction when we're solving for this equation. Now, this side also has an equal sign. And if this side also has a fraction, so you also have to take a look at this side and say, what's the restriction here? Now, the restriction here is exactly the same as the restriction here, because if you go 6x cannot equal 0, you divide by 6, so x cannot equal 0. So you get the same restriction for this side of the equation. Okay. So before we start crunching this equation, before we start solving this equation, we always try to list our restrictions. And what I personally do, and I think this is the general standard of the way things are done, is I always list my restrictions on the side. And what happens when you get more complicated equations, this is a straightforward equation, and there's only one restriction to this. When you get large equations, restrictions might pop up halfway through your solution. Okay? So what I end up doing is listing my restrictions on the side, on the right side of the piece of paper where I'm doing the work. And at the end, I look up the right side, and for my solution, I always list the restrictions. I just add them all up at the bottom. Okay? Not add them all up, but list them all at the bottom. So over here, I would say our restriction is x cannot equal 0. Okay? And then we would go ahead and start solving for it. An actual chalk. What do you call it? So what we have here is we're trying to solve this equation, right? So what we can do is cross-multiply this guy and this guy. Okay. Now here's a property of cross-multiplication that is super handy, but again, you have to be super careful using it because it sometimes removes your restrictions, or the restrictions are still there, but it removes it from your work, so you might forget to list your restriction. That's why you always list it at the beginning. When you're trying to do this, when you cross-multiply this thing up, purple is my own try. Or sorry, not purple, pink. So what you're going to do is you're going to cross-multiply this up, right? With cross-multiplication, there's a very powerful property that comes up. But again, you have to be super careful using it, applying it, is when you're cross-multiplying, anything that's similar, that's cross-multiplying, is identical, they kill each other in the middle. Okay. Now there's two ways I'm going to show you guys how to do this, why this is. But basically keep in mind that anything that comes up here, when they're cross-multiplying, whatever is similar can kill each other, okay? Or whatever contains something else can kill each other. For example, 6 you can break down into 2 times 3, right? So it's actually 2 times 3 that's cross-multiplying up here. And there's a 3 coming up here. So this 3 can kill this 3, okay? And this x can kill this x. So the only thing really being cross-multiplied up is the 2 coming to this side. So 2 times 5 is going to be 10, is equal to 3x plus 1, because the only thing that's coming up here is just a single 1. Everything killed each other from this side. Right? So you got 3x plus 1, right? Now, what you do is you grab the 1, bring it over, it's minus 1. 10 minus 1 is 9, is equal to 3x. And, no, we're still in work. So 3x is equal to 9. You divide by 3 from both sides, and your answer is going to be x is equal to 3. And that's your solution, right? Now, with this cross multiplication, when the x's killed each other, if the x's didn't eliminate each other, you would get a solution of x is equal to 0. And what you would have to do is look back at your restriction and eliminate that answer. So let's do this problem without crossing out the x's and see how the solution would look, okay? So what would happen, actually, let's, before we erase all this stuff, what would happen if they asked you to write the answer for this question? What you would do is, your solution would actually be x is equal to 3 and x cannot equal 0. And that's the complete solution for this. Okay. Now let's solve this equation again, but without crossing out the x's.